Good evening, and welcome back to the weird and the wonderful with Strange Bones. That's me. So, while I know we generally go along very much so with the more supernatural and paranormal, a number of interesting things have come up in lives, and the question of whether or not some of the more science fiction-y things are even possible. Where do the ideas come from? Is it just entirely made up out of nothing? And all the rest of it. And as a matter of fact, a number of the major tropes in science fiction are based in real-life ideas. Now, whether or not they are actually possible is another question. But at the request of some of you guys, we have basically decided to do a little bit of research and look at some of the ideas and things that are out there and try to decide whether or not we think there is reason to believe any of it could actually be possible. Now, of course, we're going to have to explain what we are talking about, and I do warn you that some of these things do get kind of technical because it ranges into quantum physics and all the rest of that. But if you're interested, stick around and check it out with us, and let's see what we think. From flying to other planets to lightsabers and laser guns and cloaking devices and more. Where do the ideas come from? And could we, maybe, possibly, one day do them all? Let's have a look at it. So we're going to need to start ourselves off with a certain amount of background. And before we do, I'm going to remind everybody that on this channel we do things for our own curiosity and interest to learn a little more. You may absolutely have whatever opinion you like, and we encourage you very greatly to comment as we go along. But do remember, the one rule we have is don't be rude, because if you are rude, we will give you the boot. And I have done so on many occasions simply because some things are just no. We don't allow rudeness. We've had a fair share of trolls, some of whom have proved to be quite disgusting, which means we will not allow you on the live until such times as we actually know who you are and you seem to be a legit person. So just so as you know, it's a rule we have and we stick to it. But with that said, Elvito, welcome. And welcome to all you other guys as well. But remember, we run this channel basically on the grounds of you. So absolutely like, share, subscribe, do all of the good things in that regard to help keep the channel going. We do need you to make things happen. Thank you for those who have just done some sharing of likes. I do appreciate it greatly. And welcome to Spooky Stream of Thoughts. How are you doing this evening? Are you in fine form?
Sorry, I didn't get that.
I say, are you in fine form?
Yeah, no, I'm good.
Awesome, awesome, awesome. So, as we promised, we did a bit of research on all of these things. Thank you so much to Storyteller, by the way, for the rose. I appreciate that greatly. Where do the ideas in science fiction come from, and are they possible? Now, this is going to range into the heavily scientific in some cases, as you may very well expect. And in some of the cases, rather sadly, I must say, the answer is a hard no. But surprisingly, and not necessarily in the ones you might think of, the answer is actually yes. And in one case, which blew my mind, it's we've already done it. So, stick around and let's begin. Now, where do we get our science fiction ideas from? Well, the biggest source, of course, is the early writers. And going back a bit, we see that a number of interesting ideas came from, for example, Mary Shelley with Frankenstein, the idea of galvanic electricity and the reanimation of things, which actually to a certain degree works, scarily enough. And maybe that's something we ought to avoid, quite harsh in that regard, because the idea of bringing the dead back is certainly freaky. But it does kind of seem to work in principle. Have you ever plugged electrics into frog legs? Because you can make those muscles work. So galvanic electricity is one topic, and it comes up in other things as well, including space travel, interestingly. H.G. Wells, of course, his famous The Time Machine, which absolutely is one goal for a lot of people and might be possible. Welcome to Caleb, good to see you. Jules Verne, of course, did all kinds of things with scientific concepts and so on. And weirdly enough, Edgar Allan Poe, better known for his horror writing, nevertheless touched on a number of scientific things. So that's the older stuff. With the newer ones, of course, we move forward very much with people that the names of the older ones you might not recognize, but you'll probably recognize some of the newer ones. They absolutely do become quite important in modern understanding of what science we hope will become true. Let us say that. We know Arthur Conan Doyle, Rudyard Kipling, they all spoke of things. I consider myself fairly well read, but I don't recognize all of these writers at all. So there is that. So don't feel bad if you don't know all of them. But nevertheless, it's through the stories that we've developed our ideas. One of the older ones, Mark Twain, interestingly enough, did A Connecticut Yankee in King Arthur's Court, the idea of the transmigration of consciousness back through time. So, yes, and the idea of anti-gravity, believe it or not. So things have been going for a long time. We know there's L. Frank Baum's series in The Wizard of Oz, which had a number of interesting things you might not think about for his time, which was between the 1900s and 1920s. He nevertheless had the idea of handheld wireless communicators. We have cell phones. Mechanical men, we're developing AI robots at this stage. So very early on, people were thinking ahead. Jack London with his The Red One, which was sort of extraterrestrials and more, the Iron Heel, and others with germ warfare and all kinds of stuff like that. And a very interesting story that he wrote on invisibility and an energy weapon. So the ideas came very early on. And from that, people actually started thinking, what if? Could we? Modern type writers, of course, came up with some really, really good stuff and developed into what became the early movies, the most famous of which, of course, are the Star Trek and Star Wars movies. But before that, we absolutely... Endless Thoughts, hey, hope you are very, very fine this evening. But as you know, George Orwell's 1984, the idea of technology that could watch you anywhere with cameras and things, well, we have that. So right off bat, that's an idea that has become real. We know Orson Welles' Mercury Theatre produced a radio version, so before even TV, The War of the Worlds, which was all about robots and aliens and what have you. So definitely that. And these things gave ideas that eventually were taken up by great scientists. Now, the great scientists we will get onto, because they started making actual the things that we would hope do come true, and in some cases we hope don't. Huge thanks here for those gifts from Endless Thoughts. That's amazing of you. I appreciate that very greatly, and I'm glad you were able to come on to the live. Fantastic, fantastic. Now, as we got to the more golden age of science fiction, and it became a genre in its own right that was really taken up, we had a number of great authors that really did some good stuff. And you had things like Flash Gordon, Buck Rogers, all the really cool things that we grew up with. Frederik Pohl, a great science fiction writer that spoke of a lot of these things. Now, some of the best, I would say, that the real iconic beginning stuff came out in Star Trek. Your communicators, your phasers, your transporters, the idea of warp drive, all of these really incredible devices that allowed you to explore the universe and do all of that kind of stuff. But with that said, was it just people's imagination? Or was it in fact really ideas that could be right? Well, let's jump across to some people that actually matter. Luigi Galvani and Giovanni Aldini starting bioelectrical experimentation, which was called galvanism, using electric currents to produce muscle contractions in corpses, which of course influenced Mary Shelley's concept for Frankenstein. And Frankenstein only came out in 1818. So this was even before that, some really revolutionary and amazing ideas. We also have Erasmus Darwin and James Lind with their ideas about life and death that really got doctors into the idea of what makes a thing alive, and electricity and electromagnetic movements in the body. We also know we have Johannes Kepler, the astronomer and mathematician who formulated the laws of planetary motion and wrote that many copied from him, including Carl Sagan, Isaac Asimov, and others, into ideas about travel through space. Kepler's story Somnium in 1634 involved a journey to the moon. So way back when, this was already going. Big stuff. Isaac Newton, Galileo Galilei, Nikolai Copernicus, They started things really going with how gravity might work, how the solar system works. Are there actual laws to nature? Now, of course, in the modern day, well, of course there's laws to nature. What's the big deal? But back in the day, this was unbelievably revolutionary. Now, of course, Darwin took things even further with the idea that we actually evolved. Thank you very much for dropping a comment there. I appreciate that massively. And then, of course, you hit the 20th century. Now, the 20th century is when science fiction as a fantasy type story took off, but so did science. And here is where science and science fiction live together. Huge thanks for those likes, by the way. So Albert Einstein, of course, relativity, mass to energy, equivalence, time dilation, foundational concepts, not only for science fiction, but for actual science and advanced physics. Marie Curie, with her work on radioactivity, the inspiration for the imagined possibility of atomic power, which in the modern day, we have atomic power. It don't always work, I give you Pripyat, but nevertheless. Alan Turing and Marvin Minsky, with their foundational work in computer science and artificial intelligence, influenced so many stories of robots or intelligent machines, which in the modern day we have them, but brought with them the philosophical implications of AI, and we're going to get into that too. And hopefully Spooky is going to give me plenty to argue with him about, because some of these things are really good. And I know he's keen on it as well. So, looking forward to. Next up, Carl Sagan, a very respected astronomer and science communicator. He was also a science fiction writer who wrote one called Contact. What would be the process of first contact with extraterrestrial life? Arthur C. Clarke, Isaac Asimov, very prominent science fiction authors who were actually scientists. Arthur C. Clarke was a physicist and a mathematician. Asimov was a biochemist, and their deep scientific knowledge allowed them to write hard science fiction that explored concepts with scientific accuracy, like satellite communication systems and the possibility of space travel, well before it ever became real. So a lot of these, especially early science fiction stories, are actually based in possible truth. So let's chuck ourselves into it and start ourselves off. Star Trek. Why Star Trek? Well, they are the ideas we best know. So, theoretical physics, the idea of tachyons, hypothetical faster-than-light particles, gravitons that theoretically mediate gravity. Now, theoretical physics uses these ideas. They are real scientific concepts that were then blended into the Star Trek science as real. Now, are they real? Well, we can't be certain, but it seems that they might. There's a certain amount of hypothesis. To a certain degree, faster than light isn't possible, but it might be. What about the warp drive? The idea was inspired by a lot of real scientific considerations. So physicist Miguel Alcubierre proposed a theoretical model for it in 1994, directly citing Star Trek as his inspiration. His model involves creating a warp bubble that distorts the space-time continuum consistent with the aspects of Einstein's general relativity. So it sort of swings between science-inspiring story, story-inspiring science. Maybe it's possible. We will go further. What about silicone-based life? Well, on Earth, we've discovered creatures that, while they are still carbon-based on our Earth, they incorporate silicone so much into their physical body that it's possible that you can actually get a silicone bond on a carbon-based life form, and it becomes necessary for that life form. Does that mean on another planet you might get entirely silicone-based life forms? It's theoretically possible. We know that the franchise had a long history of consulting with scientific experts. Astrophysicist Dr. Erin MacDonald served as the official science advisor for Star Trek. So it's carried on. What about the transporter? The transporter technology was initially created out of financial necessity because they needed a way to get up and down from the surface of the planet to the ship. But it's become something as a theory. If I took you apart and I put you back together, would you be you? Well, I do change myself in smaller ways all the time. And as I grow and get older, I do change all the time. Your cells die all the time and are replaced all the time. I have a tattoo. I'm still me, even though I'm modified in that regard. So, something to consider. What about phasers? Now, here's the thing. There's a difference between a phaser and a laser. And we are going to need to talk about whether or not it's possible. Because in certain things, yes, and in certain things, no. So there's issues. Now, with regards to all of that, what did they give us that is? Well, they're communication devices, which actually initially they were going to refuse to allow because it was just too out there. Well, we now have cell phones. The idea of a tablet computer, impossible, because at the time when it started up, it was just, you needed an entire room to do computer work that was essentially the function of one of those little calculators on your watch. Nowadays, we have them. A voice-activated artificial intelligence, that was just too much, but they put it in because it was so engaging. Well, we have Siri and Alexa, and are working on AI robots that will incorporate that. So, well, what about non-invasive medical imaging and tricorder-like diagnostic devices? Well, we're working on that too. What about the ion thruster, a propulsion system for spacecraft? That might be a yes. So, Star Trek gave us tons. It gave us ideas. And of course, you will never get anything without actual ideas. Mbambato Chalale. I do not know that gentleman. Does anyone else know him? No? Then we stick to our rule. Okay, so we've got all of these interesting things. Now, the first one to talk about is in Star Trek, you have subspace, a feature of space-time that facilitates faster-than-light transit. okay, in the form of interstellar travel, the transmission of information. So it's faster than light warp drive that allows you to drop out of ordinary space and time, and therefore move between massive distant places in moments, as opposed to you've got to have multiple generations and it's like your great-great-grandkids that actually do the arriving because. And this was one that, Spooky, you were talking about. So subspace, is it really something that could exist? We know that it's been used in the Stargate franchise, in the Hitchhiker's Guide to the Galaxy, and in Star Wars with hyperspace. Same basic thing. Do you think that there are multiple layers to space and time? What do you think?
No comment.
No comment on that one. Well, the problem ultimately, as it turns out, comes down to the idea of the speed of light. If I wanted to go to the Milky Way, even light takes years to get there. So to travel at the speed of light wouldn't even be enough. We would have to go at multiple times the speed of light. So when they talk in these scientific movies of warp factor 10, they're kind of saying that you're going 10 times faster than the speed of light, or whatever. It seems that the physics of that might be impossible, and even subspace communication, which supposedly would travel at the speeds of over warp 9.9, would still take hours and hours and hours to get to the other side, much less than an actual physical object. And we know that in the Star Trek Voyager episode, there's a particular season where they say that the barrier is warp 10. You cannot go faster even than that. And they try to break what they call is the threshold. Now, we know in history it was absolutely scientific, proved, and all the rest of it, until it wasn't, that you could not break the speed of sound. Mason, hello.
How did they know that?
Well, that was the science of the time. It was known because that's what science said.
How did they know what the speed of sound was? Shouldn't
You
they
could
have
measure
broken
it.
to know it?
No, because you can measure the speed, just as you can measure the speed of light, you can measure the speed of sound by how quick the sound travels from one point to another. But they felt that going faster than that as a human being would kill you. You wouldn't survive it. And then, of course, we developed ways to do it, and we have multiple times, Mach 1, Mach 2, Mach 3. So we've disproved our own science. Now, the current belief is that you cannot travel faster than the speed of light, but it is eminently possible that we could break our own science in the future. So it is possible, maybe.
Well, I love Carl Sagan. The way he talks, it's like poetry.
Oh, absolutely. Sagan was amazing as a writer and as a scientist, so fully agreed. And part of his great appeal, I think, is that he's not just throwing out cool terms and making it weird. He's actually basing it in at least believable science, which makes it amazing. Now, Sagan was one of the ones that brought up this idea, in fact, now that you mention him, because the idea of using conventional bands of the electromagnetic spectrum, so radio waves are one of the bands, if you could get to a high enough frequency and therefore send your signals into a kind of subspace that falls outside the normal space-time continuum, then the signals won't degrade, and you could actually communicate faster, at the very least, if not instantaneously, over huge distances. So not just like around the world, which is nothing, or even to the moon and back, which again is nothing, but we're talking to somebody in the Milky Way, say, which would be impressive. Now, it would mean that you could get the signals to reach their destination at a predictable time with either little or no degradation, hopefully, though we're not quite sure how subspace might really work, which makes it difficult. It becomes difficult, but it is theoretically possible according to quantum physics. So we're already starting to break our original ideas, because quantum physics is amazingly new if you think about it. Now, taking it from that, what about the warp drive? Well, we know that in the very original series, it was called the hyperdrive or the warp drive or whatever. The speed to reach the planet that they were going to was time warp factor 7. In other words, they are talking about the concept of bending space and time, that if you could go fast enough, at least in the original ideas here, space will bend sufficiently that you can jump between places by dropping out of the ordinary space-time continuum into this subspace level. And each warp factor is deeper into the subspace or the hyperspace, depending how you want to call it. That's the theory. We see them that they comment in the idea, and this is from modern quantum physics as well, the idea that the time barrier would break. And that's the critical point, because it's the time problem that we have getting to other parts of the universe. It's just too far. I mean, you would age and die before you got anywhere near it. They would have to break the time barrier by some means. So it's time more than space that's the issue. But we do know from quantum physics that time and space are linked, which might mean that they are at least on the right track. So here is the working principle or theory behind. Okay, so the basic functional principle of how the warp drive will work, which is the same for all spaceships, and the problems with it. So you need to have an incredibly strong energy source, which we don't have. So right off bat, you can't do it because we don't have the power. Okay, but assume you had the most incredibly strong energy source, and you could put it into a warp core, their special engine, and generating a high energy plasma. The plasma is transported into the warp field generators via the lines that are basically pipes. It wasn't that great in the early films, but nevertheless. So you create these warp field generators. The fields therefore take your ship into a kind of bubble that maintains the internal normal warp level of time and space, so you don't get flattened or exploded or whatever. So you're safe, but everything outside the warp field is separate to you. So you're in the warp bubble. Outside, space and time is distorted, which propels the bubble, and hence the spaceship, forward incredibly, incredibly quickly, bending, most importantly, time, but also space, allowing you to cross vast distances. Now, here is the other problem with it. Let's assume you could go that fast. As we know, space is filled with all kinds of debris, and if you hit any of it at that speed, even the smallest particle would go through you at rates unbelievable. So it would basically let you arrive there looking like a colander, which would not be good for your health. That's the first problem. So you would need to somehow get out of the physical realm in a way at that speed. Otherwise, it would really hurt. Huge thanks, by the way, to the follows from Dalton and to Kay. How's it? Hope you're having a wonderful night. So, yeah, we've got problems with the physicality of travel.
Can I say something?
Yes.
Okay, well, if you look at a black hole, you can see like a ring around it.
Yes.
Sometimes you can see galaxies behind the black hole.
Yes.
Because the light warps around the galaxy. I mean the black hole.
Yes.
Now, if you warp space in front of you and expand it behind you, you'll probably have the same effect. So particles would actually warp around you.
Yes.
Go straight through you.
And that is exactly the next point they made. So while you couldn't fling yourself through space at massive, massive speeds, because that would kill you, nevertheless, if you went through what they call a quantum singularity, either one you create yourself or an existing one, which is basically a black hole, space will warp around you, and therefore possibly you could get through it without being perforated, as happens with black holes. So the first question is, could you do it through an existing black hole? Potentially, if you can create that warp bubble around you to protect you. That's the key element. Could you create a black hole and do it there? Possibly, but again, you need that warp bubble. So that's the key thing. Quantum singularities. Yes, because if you don't do it, A, you'll be perforated, and B, the problem with massive amounts of speed is while it does obviously speed you up and it does warp both space and time, not only does it turn you into a colander, it increases gravity. So the faster you go, the harder the gravity, and eventually you will just go, and that will be the end of you. So you will arrive at the other side, great, but you'll be an atom's thickness flat and full of holes. And that...
Once you reach that speed, how do you stop?
We haven't even got to the braking system yet. Yes, that's the other problem. How do you stop? So, and of course, deceleration means gravitational pressure in the opposite direction, because that's really what braking is. It's a gravitational pressure. So you have to deal with two ways of gravitational force on top of everything. Now, that's where the quantum singularity might fix the idea, because through a quantum singularity, you don't have speed exactly, you have instant acceleration, which isn't the same thing. So here you will go from dead stop, instant massive speed, to dead stop. So from your perspective, you're fine. It's when you get that side you need to be able to accelerate again, and in space there is a problem because you've got nothing to thrust against. But there might be an answer to that. So it all comes back not to the ability to get the speed or to get across, but to whether or not you can create a singularity to go through and have that bubble around you that maintains your space-time continuum so you're not affected by everything else. That's the key. Now, in terms of the braking and the accelerating, once you've gone through, there is an answer. And the answer is gravitational sling, which we use to get our rockets to the moon. Basically, we use the gravity of the Earth like you do a sling, which you swing around and around and around and around, and it gets faster and faster, and when you release, it whips the stone out. We do exactly the same with a rocket. Now, potentially, if you could get out next to a planet or large body, you then harness that to create gravitational sling to give you forward motion to get to wherever next you need to go. So you would planet hop between, as long as there are sufficient within the system to keep you going. If you got there and the system was empty, you're kind of SOL.
Wouldn't the system help at all? Because I mean, you can probably manipulate it if you want to, because you're essentially like a black hole. You've got an immense gravitational pull.
Well,
So if you're in a star system, you're probably you are creating more gravity than everything else in that solar system.
therein lies the next problem, okay, which is that if I create even a very small black hole inside our solar system, it will have devastating effect. Yes, I could accelerate off its gravitational field, which would work, but it might pull all of the planets out of alignment and crash us into the sun, and that would be bad.
Yeah.
So you don't want to get there and be like, I've made it, I'm safe. Look, there's aliens and they're all waving and happy to see me. Oh dear, I've just created a black hole and sucked them into the sun. We're dead. That would be bad. So for every answer that we have, there's also a problem that needs to be considered. Now, if you could create a small enough black hole that it only affected the bubble you were in, then you're on a win.
You're also going to have to stop while inside the bubble, because if you're traveling at that speed and you suddenly stop the bubble, then all those particles are going to crash into you.
Well, that's why the bubble itself is the biggest challenge, because you're going to need to make it that inside the bubble you remain in a sealed space-time continuum that's not affected by the outside. So from your perspective in the bubble, you're not moving at all. So you're fine.
Yeah.
As long as you maintain the integrity of the bubble. If when you get there, for some reason there's a breach in this bubble, or it collapses, you will then suddenly be traveling at the speed of whatever is inside a black hole, and yes, then you go squidge and explode. It'll just be like,
Yeah, you'll probably explode.
yes,
Because then you're trying to travel at the speed of light as a particle.
yes,
So,
and you're both accelerating instantly and immediately stopping at the same time, which would not be
yes.
good. No,
No.
that would definitely ruin your morning.
Yeah.
So yeah,
Every
the
particle would
bubble.
probably explode.
Well, not even just explode. You would literally atomize.
Well, all the atoms would explode.
Yes, which might in fact make you into an instantaneous thermonuclear explosion,
Yeah.
which would be even worse. So yeah, there are challenges to warp drive. That said, at least as far as we understand things at the moment, we do know that it's the only possible way to do extensive distance space travel. If we cannot break the time barrier, we just can't do it. Yeah. Now, we can't do it without breaking the time barrier, because even besides the fact that it would be your great-great-great-great-great-great-grandchildren that arrive after you've left to go to the Milky Way from here, you also have to deal with the reality that we simply cannot contain sufficient fuel to fly that far. It just isn't doable. You would have to, as you go through the different star systems on the way, manage to avoid the gravitational pulls, avoid random meteors, or whatever. You have to fly around things. All of that
Probably
would.
have to carry a star with you because you need all that energy.
There you go. And that is where radioactivity might be the answer, because essentially radioactivity is star power. But our radioactivity is really, 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 really weak star power. And we don't handle it very well at all. So if you've got actual sun-type strength star power, the shields that would be required to protect you on the ship where it is would just be like, my God. Your ship would be 90% shields just to protect you from the energy source. So, yeah, that's a bit of a problem too. Can it be done? Hard to say right off bat. That's a tough one. I'd like to think we'll get there eventually, but we cannot as we stand.
Probably not humans. Maybe a distant, evolved being.
Funny you should say that, because there was a very interesting argument I came across, and it was an argument in science fiction writing, okay? So it was never meant to be real, but they were putting ideas out. And they were saying, what if, okay, picture in your head the Greys. You know the Greys, okay, what they look like and everything. In their argument, humanity managed to get off the planet, but they evolved out there for all the reasons that things do in a different environment, and when they came back, the greys are actually us in the future. Bigger heads, smaller, weaker bodies that are not needed for extensive labor, used to zero gravity more than the strong gravity of a planet, etc., etc.
Yeah.
It's an idea that shows the
Yeah.
challenges.
I think we would probably evolve into machines before our biology actually changes.
That's a very fair comment. Disturbing, but very, very fair. Mickey Mew, welcome, welcome. So absolutely, it's a possibility. But then on the other hand, are we going to say that maybe real evolution can include mechanical evolution as much as, and maybe we'll talk biomechanical? Hey Mickey, how you doing?
Hello. Okay, thanks, and you.
Good, good. Quick quiz for you. Which would you prefer to be? Biologically evolved or mechanically evolved?
Probably biologically evolved, I'd say.
You see, because here's the thing. In more than one novel I've read, at least in science fiction, they've developed the robotics to a degree that it's no longer mechanical robotics, it's biological robotics, which makes it genetically compatible to a human body and therefore is a kind of forced evolution. Now, obviously,
Yeah.
that's not really possible, but imagine if it was.
Are you
Now,
saying it's not really possible, or it's not possible at current times?
at current times. In the future, I really wouldn't know, but at current times, no. But we do know that they have at least been working on nanotechnology for non-intrusive surgeries, that you
Yeah.
create such tiny, tiny little surgical robots that you come in and say, oh, I've got cancer in my lungs. I introduce the robots into your body. They go in, excise the cancer, repair your body and everything inside you without anybody having to cut in or do anything or use drugs and things. It
Yeah.
deals with it for you and then they come out.
Yeah, that'd be pretty cool.
So it's a possibility. Is it a reasonable possibility? That's another question. We are asked by Riyadh 10 if he can join. Anybody know them? Shall we give them a chance?
Sure, why not?
Okay, we're going to go for it. But remember the rule, if you are rude, then we do terrible things. Okay. Hey there, how are you doing?
I'm good, and you? How are you doing?
I'm very, very good. So, we are talking about whether or not it's possible to fly to, say, a place as distant as the Milky Way using the fictional idea of warp speed. Is it something that might be scientifically possible?
I think so.
Okay, so we have a believer. Why do you think so?
I have no reason.
So, like many of us, we absolutely hope so, but whether or not it could be is another question. Now, as we've been discussing, there's a lot of problems facing actually doing it. Really a lot of problems. But in all fairness, problems are things that we absolutely do try to overcome, in all fairness.
Yes, 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 yes.
So, I mean, as we said in the beginning, it was a known fact that you could never exceed the speed of sound because that would absolutely kill you.
Obliterate you.
I mean, you would just die. You would never be
Oh,
able to break the speed of sound. Now, having that said, we now know, of course, you can break the speed of sound. We do it all the time. So the science then, that was a known fact, we've disproved.
yes.
Okay. The science now says we know you cannot break the speed of light. However, potentially, in the future, you see. Okay, so before we go on, quick saying, guys, a number of you are asking to join. Normally, we do not allow new people to join because of the trolls we've had in the past. And especially, we require people to be at least of a sufficient number of followers and things that we know you're real and not a quickly made account in order to troll people. So I'm afraid
Yeah.
Riyadh
Yeah.
got accepted because,
My aura.
but the other guys, we are going to have to be a little bit circumspect on in that regard. But nevertheless, moving along.
Yes, let's move along.
Fictional history, yes, of course. It worked wonderfully in a lot of different stories. And the
My aura
theory,
is great.
say again,
I said, so when you talk about the aura of the universe,
the aura of the universe,
yeah.
I am not familiar with that.
So basically, it's like the Milky Way, right? And you see how Pluto is not regarded a planet,
Yes.
right? So Pluto is not regarded a planet because of the aura of the Milky Way.
Oh,
But it's just fictional.
well,
Yeah,
yes, that's basically more fictional stuff to make things
yeah,
sound good in that regard.
yeah, yeah.
It's a dwarf planet.
But we will say that technically, if you
Yeah.
could overcome the need for what we will call a warp bubble, and you could provide sufficient power,
Yes.
you then could achieve warp speed. Now,
Like the Flash.
yes. So Faizine's got questions. You may absolutely put them into the comments, and we will definitely try to answer them.
Yes,
You are
sir.
welcome to do that. Chufi, I'm not going to allow you to join because you're an unknown and not enough followers at this stage. Be on our live for a few times so we can see you active, and we will give you a chance in the future.
Can I explain something to you, if you
Yes.
don't mind? Right. So let's talk about time traveling, right?
Yes.
When you time travel to the future and change something, you actually create your own timeline. Did you know that?
Well, okay. Now hold on to that thought because we are going to
Okay.
get to time travel.
Okay.
However, it does apply to warp travel because while
Yeah.
you are
Yeah.
not going to be moving backwards in time, you are going to have to, in a sense, move outside of time
Yeah.
because otherwise by the time you arrive at your destination in the Milky Way, you'll just collapse to dust because you'll have aged massively. So your warp bubble has to overcome time and space and allow you to maintain it inside the bubble so you don't explode, because that would be bad, but move through what is outside the bubble. And that's the problem. because otherwise you'll do it, and when you arrive there, you'll both accelerate massively and decelerate massively at the same time, and you will explode an atomic level.
I have a question. I know you're not an expert, but how fast do you then actually travel?
You
What
would
in
have to be
space?
several times the speed of light.
I can answer that one for you. You have to be at Mach 12.
Mach 12 is really, really slow. That will never be enough. That's only
No,
12 times the speed of sound. You would need to be at least 12 times the speed of light.
oh,
But even 12 times the speed of light would still be slow because it takes light millions of years to travel from Andromeda to us.
Correct.
you know who actually did it? Superman.
Well, yeah, in stories.
Yeah. Love Superman.
Well, yes. But right there, that would be an issue. Okay, so moving along to the next interesting thing. We're talking about either you've got to fold space so that you instantly transport between two places, or you have to get into the quantum slipstream outside of the normal space-time and shoot across really, really incredibly fast, or the one which Spooky likes, either create or go into yes, create or get into an existing wormhole, so in a black hole and out a white hole, that allows an automatic geodesic fold, which also overcomes the possibility of or problem of space debris. But other than that, no problem, because if you go into a wormhole, you accelerate with maximum gravity, and therefore you become one atom layer thick. And yeah, that's not good for your health. So all methods are theoretically possible, but have major problems to do. Okay, so wormhole, that's warp drive kind of covered as much as we are able to. So we can't done something wrong.
My favorite, or probably the fastest way to travel, would be using quantum entanglement, where you manipulate atoms at somewhere else to turn into you.
Okay, now that is now your transporter. So in other words, warp drive means I take you and by some means accelerate you through across the distance to there. Okay, so we're talking traveling. A transporter works entirely differently. It dematerializes you, making an exact map of you somehow, and then using material on that side instantaneously, recreating you from the map that you have, making a new you, but there instead of here.
Yeah.
Yes.
That way you can, well, not probably travel. Well, you are traveling.
Kind of, yes. Because ultimately, are we consciousness? Or are we the entire thing?
No, I wouldn't know.
Right? Now, here's the other advantage to that. If, let's say, I could take Mickey, map her exact personness, and transport the map
That
across
information.
and reform her. What if I discover, hey, Mickey lost an arm in an accident, but now I've got the map. So what I do is I transport her not from here to there, but from here to here, reforming her with the original map with an arm not lost,
That'd be cool.
right?
Okay.
Or better yet, 40 years from now, she's old and tired, but you know, so I transport her into that map with her knowledge, etc., but as a 17-year-old again.
Or you could make me a fly human hybrid like in The Fly.
Well, therein lies the problem, because what if somehow I got a computer virus into your genetic map and screwed it up somehow, or mixed you up
No.
with the computer map of a fly, and all of a sudden we've got a problem.
Ball of motion.
So
Yeah.
the possibilities are huge. The problems are equally huge.
Yeah.
Don't get the map wrong.
Yeah. It's gotta be like really.
So if I could map your consciousness and knowledge, and then create a map alongside it of your physical self, when I sent it across, I could take the most current mental map and take a really good, strong, physically healthy, decent physical map and reform you out of that. I mean, look, I would love to be 17 again if I could have all the knowledge, learning, skills and everything I've got now. I mean, that would be cool, right?
What would be cool is what you could do is like if technology was like that, you could cryogenically freeze the body. Like say now for instance, like what you're saying, say now I was sick, I had some problems with my lung or
Right.
whatever, and we were hoping that in the future there would be a cure for whatever the lung issue is. And you freeze the person cryogen anyway, and
Yes.
then a couple of years later you can like yeah, I don't even know what I'm trying to get at. But
Well,
anyway, if there's a cure for that disease you can
then cure it
yeah,
then. Well, again,
yeah,
cryogenics is another science
yeah,
fiction-y thing we've tried to do. And there are problems with it because freezing does cause damage and degradation to cell structures and stuff. But if what I had was just a genetic map, I could
yeah,
go into it and say, well, that bit there is the cancer bit, so we edit that out. And we'll keep the bit where you've got all your arms, legs, and kidneys and what have you. And we'll,
Put someone in a hibernation pod.
yes. And then
But
we
if you
would,
have a virus, will the virus also hibernate?
well, there's the other thing that they've never answered in science fiction that I wanted to know about and couldn't find. Let's say, unknown, you have a disease. And so I'm like, we're going to put you in a hibernation pod and we're sending you off to the Milky Way to one of the planets there. Great, no problem. Only on the way, as you're being transported, the disease now mutates, changes, and modifies you into something entirely different. So we get to the other side, pop the pod and go, hey, Spooky, how are you? Oh my God. And this alien jumps out and bites your head off. It's potentially an issue.
yeah, for sure.
You see, these are things that are problematic, and we don't have answers yet. So yes, there are issues. Now, moving along, what about the medical technology? Because that is really cool. Now, they have hypospray, which is like, okay, basically you've got this giant gash in your body and so on and so on. So we basically spray over it and it keeps you intact until your body reconstitutes and heals. Now, this is pretty cool. We do, in the medical field currently, have what they call plastic skin, which is imbued with antiseptic properties and antibiotic properties that literally I can spray on an open wound to seal it so that you don't get infection until your body heals. So it does exist in a way, which is pretty damn cool.
Yeah, it is very cool.
Now, it's not as advanced as I give you like a clear gel type fake body part that works just like your normal one until your body regrows the old one, like in the science fiction stuff, but nevertheless, it's
It
pretty
was like
damn
an
cool.
it was like an iRobot. The guy had a fake arm, and
Yes,
he sprayed that stuffy. Excuse me.
exactly like that. So
Mhm.
the medical sprays do exist. The next interesting one is the tricorder, a handheld sensor that lets me basically scan your body and, oh, right, you have the following sickness. It's read that this and this, and you've got a break in your left toe or whatever. That we can't do.
Star Trek.
Yes. However, we do know that you can use a number of things to scan a person. We use radioactive isotopes to see if you have a broken bone. We know that there are a number of things that will show up under certain light wavelengths that we do use. We have MRIs and CAT scans. So we kind of have at least the start of
I'll
this.
be right back.
Cool. So there is at least a beginning idea of a tricorder, which is pretty damn cool. But we are not there yet, alas. Thanks for the share there to V's. Do appreciate. Now, you remember in the new one you've got Geordie LaForge with his fancy visor thing that wraps around his eyes. Yes? He's the black guy with the weird glasses type thing over his eyes.
Okay.
It was in Star Trek The Next Generation. Now, he is in the story a character who is blind. This visor connects up to his brain and allows him to not only see, but see in multiple different ways, depending on, which is pretty cool. Now,
I know Elon Musk said something about that using the neurochip,
yes.
and you can connect eyes to your neurochip.
Now, here's where things get really, really cool because, first of all, I think it's called Google Glass. They're like glasses, but they're connected to Google. And I can have maps on them, I can have info on them. I can walk up to a statue and it will pull up for me automatically all the details, who it is, why it's there, why it's important, the historical stories, whatever. We have that. We also know, as you said, that we're working on implanted chips that will stimulate the nerves that your eyes would stimulate if they worked, with the idea that if you're blind, we bypass the eyes and you see anyway. So if you combine your Google glasses with that, technically, not only could I allow you to see, but process all kinds of information about what you're seeing as well. And if I could take it off your glasses and implant it directly in your eyes, then you could literally, but there again, now you're partly a robot.
Yeah, you're a cyborg.
you're a cyborg. So it is almost possible. So it's not just theory at this stage, it's almost doable, as long as you don't mind being a cyborg. And here's the other problem I have with that. Let's say that, okay, I'm blind, I'm deaf, so you implant all these things to sort me out and it works great. What happens if I get a virus?
Or you get hacked.
Or I get hacked?
You'll be able to control people.
Right? People could control people. People could force you to sit and watch spam advertising 24/7. And what if you got malware and everything now just goes weird and then you go completely crazy and start killing people randomly?
Well, I keep on thinking about this one subject. It's viruses and
Yeah.
secret organizations.
Yeah.
Do you think that people have already developed all sorts of viruses to wipe out a large amount of the population?
I know they have.
They're
Yeah,
just
for
waiting for certain countries to get destroyed, maybe like the United States.
I will tell you a terrible thing, but it's nevertheless something which I actually read an article on, and you may put in whatever political or sociological agendas as you see fit for what was the reason why. But now they were looking at genetically modified viruses that target specific racial groups. So I, as a 100% pure Caucasian, could be completely immune to what another race would be absolutely deadly for. And then all I do is I just release it everywhere, knowing that I'm fine. You're all gone.
I've got a virus that I thought of that might work. It's like a zombie virus. It's a enhanced rabies virus. It does everything that rabies does.
Okay.
You don't want to drink water. You don't want to eat, and you're extremely aggressive.
Okay.
And yeah, so you just run around and attack people.
Yes,
and
which is what
infect everybody around you.
advanced stage rabies will make you do. Yes.
Yeah, so it's essentially it turns you into a zombie.
Well, I know for fact that research has been done into these things. Rumor has it that the COVID virus was an attempt that failed at creating this because it was meant to affect only certain groups of the population, and it turned out it was just too strong and it affected everybody, and it escaped the lab in Wuhan. And there is reasonable reason, though no certainty, that COVID was manufactured.
No, it was.
Oh no, I mean, look, if you were to ask me my opinion, it was. But
Well, COVID
hardcore
existed way
science.
before it actually humans started getting it, because it used to be bats had
Well,
it.
basically, at the end of the day, COVID is just the common cold, but hyped up on steroids. So
Well,
somebody
they
hyped
used
it up on
COVID.
steroids.
Well, it's a virus that spreads quickly, and that's why they
Yes.
target COVID.
It's the same as
Because you
bird
want
flu.
something to spread very quickly.
Yes. It's the same as bird flu. The reason we call it bird flu is that humans can't get it. Except now you can.
And swine flu is a
Yes. So somebody made it that you can. There's your conspiracy theory right there, in your face. Bring it on. So yes, we've absolutely got that. Now, the last one in medical that we've got for you is your emergency medical hologram. So the doctor in one of the later Star Trek series isn't actually a crew member at all. It's an AI hologram who can then interact to a certain degree using robotics and what have you, and diagnose and so on. This is actually very likely going to be possible very soon. We already have AI that can give opinions and what have you. All we really need to do is set it up in an environment where you have sufficient cameras to test and read your heat signature and so on and so on and so on. It's just a holographic projection so that you feel like somebody's there looking at you. So is this possible? 100%.
Yeah.
There's no question about it. So yes, let's now go on to fun things. Okay, so the communicator is already real. You have a cell phone and you're probably watching me on it. The transporter, we've said, is a no-go at the moment. What about the universal translator? We have them. They exist. You can download a AI device on your cell phone. I don't know how well they work. I've never tried one, which will listen to what somebody says and translate it into the language of your choice. So say Mickey speaks only German, Spooky only speaks Russian, and Endless Thoughts only speaks Zulu. I only speak English. I can have the translator going, and anytime one of you speak, it will pick up what language it is, translate it into English, and feed it back to me. What
I would
we...
be more interested. Oh, sorry.
No, go on.
I would be more
My
interested in
keyboard does it.
Okay, wait, hold on. You both spoke at the same time here. Mickey,
Sorry.
go on.
No, I would be interested in the translators that can translate animal sounds to actual human language.
They've got prototypes of that as well.
Yeah.
Whether or not
That'd
they
be
work is another question. But languages between humans does. Not well, but it does. Spooky, you're up.
No, I was going to talk about my keyboard, which has a translator on it.
Yes, it does.
And
Now
I've
that's-
also got speech to text.
Correct.
So I just talk to my keyboard, and it translates it immediately and sends the message to whoever in any language.
Correct. But they actually have an AI version now that does all of that real time.
Well,
With
ChatGPT can do it, and Grok can do it. You can just tell you just tell it.
But
I want
but
to.
what makes it cool is the latest one will speak it aloud. So you only speak
Yes,
Russian.
no, that's what it does.
Yes.
Have you never used AI on a voice feature?
No, I've never done it. But it is real and it works today, is the point.
I've used it many times before. It speaks Afrikaans as well.
That is kind of amazing if you think about it. So I can have a conversation with somebody else who doesn't speak my language, that I don't speak their language, and it will talk between for us. And it will
Yes.
work. That's
It works perfectly.
pretty damn
I've
cool.
used it a couple of times.
Okay, so there you go. We have that one. The transporter, no. The replicator. Now,
Mickey 17. It's a movie. They reached an alien planet, and these aliens were talking into a language actually, but the humans using their advanced technology, they were able to translate what the aliens were saying.
which is pretty cool.
Yeah. I'm
Now,
not sure if you saw Mookie 17. It's a 2025 movie. The guy
I've
was
heard
also.
about it.
They kill him. Or he's like
Oh,
an
well,
experiment on the ship.
shit.
And they keep on printing him. And then they kill him.
Yes, and it's called 17 because there's 17 of him. They over and over again
Yes.
test to destruction, yes. Now, there is also, and I have seen it, now I'm not going to claim it really does work because it's very difficult to get feedback from an animal, but I've seen one translator that works for cats and one that works for dogs. So
Oh,
you can understand what they're saying and they will understand you theoretically. It does exist today. You can download the app.
wow.
So it does exist. Now, what about the replicator? Now, the replicator, in case you don't know what the replicator is, it's basically got the building blocks of atoms in it, and you go up to it and say, I would like a cheeseburger. And it forms a cheeseburger out of the material it's got, but it will be a real cheeseburger. And then I can go up to it and say, give me a glass of whiskey, and it will give me a glass of whiskey. It forms it out of the base elements of reality into whatever it's programmed to make. Now,
Because essentially everything is made out of the same material.
Correct. Now,
Just formed and put it into different ways.
yes, we can't do it yet, but there is such a thing as a 3D food printer that they have made that will print you food.
Have you seen the movie Cloudy Over Chance of Meatballs?
Yes, I have.
It sounds like a
Well, yes, but imagine you don't go shopping except for, like, I don't know, a block of base materials to slot in your machine. But then when you want dinner, you just go, I feel like sausage and chips tonight. And it goes zoop, 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 and then you have sausage and chips. Just like, you don't get different groceries, you have that.
sounds easy. But
So,
boring.
well,
Cooking
I,
is fun.
How much waste food would there be?
I suppose if you only ever ate one kind of food, you might have a lot of other elements left behind. Like, well, you're always eating sausage and chips, so the healthier stuff never got into it.
Yeah.
So there's that. But we do have 3D food printers that will print you a cake. So we're working on it. Now, the next interesting two, what about the tractor beam and the cloaking device? Tractor beam first. According to the research, it's a theoretically possible thing, absolutely. You can do it. Basically, what you're doing is creating a gravitational field that you can direct. Problems with it. Gravitational fields are not directable at the moment. Okay. If they were directable, then yes. Secondly, we cannot at this stage create gravity really. But maybe we could. What if we were... Okay, so gravity is created and forms what we call the planet's albedo. Okay? This is how gravity works on Earth. We have that gravity because of a number of factors, most importantly, the spinning of the Earth. If the Earth didn't turn, we wouldn't have gravity.
Yeah.
However... Sorry?
No, I'm saying we would have gravity.
Oh no, gravity would exist. We wouldn't have gravity. But the problem is we stay where we are in space
No, we
because
would
we
still
generate an
be on
albedo.
Earth. If the
No,
Earth stopped moving, we would still be walking on Earth. It's
no,
just we'll be burning in the sun.
no, you wouldn't. If the world stopped moving, gravity will fail and you will float off into space. More worse,
No.
no, you will scientifically.
Well, the moon isn't spinning, and people walked on the
It
moon. They
spins
didn't float
around
off.
us. It's in our gravitational field.
Yeah, but Earth would be still be spinning around the sun.
No, we'd be sucked straight into the sun. What keeps us in space in
If
our
gravity
position
stops, then the whole Earth would also
crash
be
into the
no
sun
more because gravity is holding the Earth together.
as well, but we would be sucked straight into the nearest gravitational field, which in our case is the sun. We stay where we are precisely because of the particular albedo that we have, which is why on every other planet there is a different albedo and a different gravity. That's why it's where it is. If it was exactly the same as the Earth, it would be where we are and would crash into us.
I only know one way to create artificial gravity, and that's spinning things in a circle.
Correct. Now, if you could create it and direct it, you could make a tractor beam. The problem is spinning things in a circle isn't directable
No.
at the moment. But if you could, then a tractor beam would be doable. It's theoretically doable, but not practically, if that makes sense. But yes,
Tractor. Are you sure they use gravity and maybe not like magnets or something?
well, if you, we could probably, it would have pretty much similar problems, but you could use magnetism, but then it would only work against metallic objects. Whereas the idea is a universal tractor beam that no matter what it is, I can reach out, grab it, and pull it in.
Okay.
So say you fell off the spaceship while fixing it and were floating off. I flip on my tractor beam and suck you back to the ship so you're safe. But you're not ferrous.
So gravity would work best.
Yes. That would, if we could direct it as a beam.
And
And
we do
it's,
have iron in ourselves, so
yeah, but not enough
can
to
it
be
get cool?
properly magnetic. And the other problem is if I made it, the magnet strong enough to attract the iron in you, it will affect the electromagnetic field in your brain and turn you into a vegetable.
Yeah.
And that would be bad. So there are issues. But if you could create a directable gravitational force, that would be different because that won't affect your body's function. Theoretically.
What did you mean by cloak? Like invisibility
Aha!
cloak? Makes you
Yes.
travel?
Yes. Because the answer to that one is we've done it. How cool is that? So,
The invisibility cloak that makes you travel.
no, this is cloaking device so that you can be invisible. Okay. So we will then give you a little bit of background on the other things that we talked about, just to bring you up to space. The first cell phone was in fact made in 1973 by Martin Cooper of Motorola. And it was really cool because it only weighed 2 kgs.
Wow.
Yeah, right?
You don't want to carry that thing around.
I remember the first cell phone that I got, I could use as a self-defense weapon and it wouldn't break. I could have beaten you to pulp with it.
Okay.
I mean, it was like a foot long and it was thick and it weighed a freaking ton. And it had a big aerial on it. But it did what it did. it worked. Okay, so absolutely, that's what you need to know about cell phones and how they became. The first smartphone was only made in 1994, which is
Really?
really recent. And it was,
Wasn't it 2010?
no, it was made by IBM, and it was called the Simon Personal Communicator,
And what made
1994.
it a smart device?
It did more than just make phone calls, basically.
Okay.
The late 20th to early 21st century, technology has seen things going up to 5G with higher data speeds, and now we can do photography, multimedia playback, videos, internet browsing, and essentially your cell phone today, guaranteed, is about 3,000 times more complicated and effective than what put the first man on the moon. What they put the first man on the moon with, that computer, was the equivalent of an ordinary, super cheap calculator.
And it was the size of a building.
Yep. And it broke partway through, and they were panicking, and the person who fixed it was Jack Black's mother while she was pregnant with him.
Really?
Really true.
Is that old?
Well, it was his mother, and she was pregnant. It's not that long ago.
Yeah.
Okay, well, it was what, 1965?
It really wasn't that long ago. 65 is the other day. Jack Black's big man with grey in his beard.
Okay.
Yeah. So there you go. That's cell phones. Tablet computers. First one comes out in 1960s with the RAND tablet and the conceptual Dynabook of Alan Kay. You had the GridPad in 1989 and varying models in 1990 with actual styluses. But the modern touchscreen tablet era only came out in 2010 with the iPad by Apple. The iPad was basically a notepad and a calculator. That was it. That's what it was. It
Yeah,
really... Say again?
I still got my laptop from college. And that was in 2008.
Right?
And it hasn't got Wi-Fi on it. You can't connect to Wi-Fi.
Right?
It's so heavy. It's
Well,
not even running.
computers actually managed to assist with tablet computers because the GridPad could run, wait for it, MS-DOS.
Oh, wow.
Right? And now you realize how far we've come. Okay, so what we saw in the very early Star Trek stuff is now real. Voice-activated computers. Oh my God. This one will
Siri.
surprise you. The first one was made in 1952. And it was called Audrey, and it was Bell Laboratories with the very first speech recognition system. And it was capable of recognizing spoken digits 0 through 9 with almost 90% accuracy, but only when used by its creator. It couldn't understand accents or other people.
Can I say that was AI?
Kind of, yes. It was the beginning of it. In 62, IBM had Shoebox that could recognize 16 spoken English words and perform basic arithmetic from a spoken input. That's pretty damn cool right there. I'm just throwing it out there. Nowadays, of course, we can ask Siri strange things and get really sarcastic answers. So there you go. I mean, virtual assistants, we've got Google Assistant 2016, Alexa 2014, and Siri 2011. Interestingly enough, Alexa comes from Amazon. Who knew? I did not.
I thought it's Apple.
No, Siri was Apple. And they were the first, and it was in the iPhone 4S, which is why they were so popular at that time, because they were the only ones who could do it. Google Assistant in 2016 is a lot more accurate in its input and handles other languages better for now. But they're all fighting, and so by 2025 it's probably changed again. But as of now, non-invasive imaging scanners in medicine. This one's going to blow your mind. The first one was used in 1895, the very first X-ray. Yeah, that was a long time ago.
Did you say 18?
1895. Wilhelm Röntgen. Discovery of X-rays in order to look at the bones of the body.
Yeah.
1940s, first used in the late 1950s for obstetrics. Ultrasound from Carl Dusik and Ian Donald. Computed tomography, I don't even know what that is, was 1967, where, okay, so it's a kind of a CT scanner. We're using X-rays from multiple angles in computer processing to create a detailed cross-section of an image, including soft tissue. Okay, magnetic resonance imaging, MRIs, for if you watch your doctor programs. Felix Bloch, Edward Purcell, and all of that team. 1950s, the principle. 1970s, actual application. So, in other words, able to do an image of soft tissue without ionizing radiation, because X-rays are a problem for that. And then finally, the most modern version, the PET scan, which was 1974, is a positron emission tomography. James Robertson and others, radioactive tracer to produce functional images of the body's metabolic activity, which is now combined with CT and MRI for enhanced imaging. And they...
What do you use to look at babies?
I don't want to answer that because I'm really not sure, because babies are a special case because they're so sensitive. But that's a good question. I don't know. That's a very, very good question. But we've more. So, advanced propulsion systems. What might work? As we've said, your nuclear fusion engines won't make us go fast enough, but they'll make us go a hell of a lot faster, which is also useful because it lasts so long. So it won't get over the problem of needing to warp between places. But once I am out there and I need to get around, this is a fuel source that will keep going.
How does it create propulsion?
Nuclear fusion is atomic propulsion anyway. It basically is a controlled atomic blast. The important part and the problem part is the controlled word. Because if it's not, you've got serious issues. Just throwing it out there. But it is a viable fuel source that will last for centuries.
You'll blow up all your equipment.
Well, the shielding's an issue. I didn't say it was necessarily a good idea yet.
It's like a atomic bomb.
Kind of. That's the broad, long and the short of it. Yeah, exactly that. Now, your favorite, ion propulsion, it does provide a lower thrust than nuclear fusion engines, but it's even more fuel efficient and can achieve high velocities over time, making it incredibly good for a long journey because it just keeps on providing.
But it's going to run out of fuel.
No, it won't run out of fuel. That's the thing. Not for like century. So very, very good. But you still have to travel between the points.
But it's like a rare material.
Possibly not. It depends if we can manage to generate the ions synthetically. That's the big jump. And I believe, in theory at least, it's safer than nuclear. Last technique, gravity assist, where you're literally using different bodies in the galaxies to keep slinging yourself. Jing, 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 jing. Which is the other thing, which would probably be really good because you don't need fuel per se. Theoretically.
You'll also be traveling very slow.
That's the problem. Now, your answer to this, and no, you cannot do this, interdimensional travel. Either between wormholes or some other way of getting into the Star Trek subspace where you've moved out of normal time and space and get to a level whereby a day's travel over a short distance equates in this time space-time continuum millions and millions of miles, and therefore you've jumped the distance. But no, we can't do it, sadly. So, can we do interstellar travel? No, not yet. Is it possible? Maybe. The problem is we can't even do it with communication and radio waves and stuff yet. So the idea of physical movement is probably going to be a long way in the future. There are just too many difficulties. The energy required, the time problem, the problem of interstellar gas and dust that you would have to go through, all of the hazards and so on and so forth. So, yeah, the amount that we have to overcome is huge. I mean, just to get to Alpha Centauri is 4.3 light years. That's just like, damn it. You want to get to Sirius, which is a pretty close star, universally speaking, it will take you 8.6 light years. So,
But you can't travel that speed, so it's actually going to take you hundreds of years.
yeah, at the moment. So, at the moment, forget it. It's not going to happen. Could it in the future? Well, now you asked what the science behind an ion thruster is. Very basically, it's this. It uses electric fields to accelerate ions or charged atoms to such a high speed it produces thrust through Newton's third law. The process begins by creating a plasma, a state of matter containing ions and electrons from a natural propellant gas like xenon. The plasma is forced through a grid system where an electric field pulls the positively charged atoms out of the thruster at high velocity, which will then propel the craft forward really fast. Okay, so firstly you need to create charged particles, ions, from a neutral gas. We have xenon. It's done by bombing the gas atoms with high energy electrons. That collection knocks them into a positively charged space, which then creates the acceleration. Now, as the ions are expelled, the electrons are re-injected into the ion beam because they
It's not a fusion thruster.
No, it's not. Which means technically, as long as I keep the xenon contained, I would have an almost permanent fuel source, which is good. Now, the propulsion comes from Newton's third law, where it's the idea of action and reaction with opposing forces, which gives the opposing force makes the ship go one way and everything else go the other way. So it propels the ship forward. It's very simple in theory. Actually doing it, of course, is something else entirely. How safe is it? I have no clue. I don't know that I would want to be the one to try it.
Well, if you use magnets to contain it, because the magnets would be your shield source.
You are correct in theory. Again, in theory, but actually doing it, then there's the problem. They're working on it, though. So it is a possible, and I think it would work probably first within an atmospheric condition where you actually have other ions and things to propel against far more effectively in that regard. So maybe we can make a car that doesn't need more fuel. That'd be cool. Yeah, I like the idea.
It's going to be a big car.
Well, it depends how big the ion field needs to be. I don't know. That got far too complicated for me to understand, so I gave up. I'm just saying. Now, here is why you cannot travel faster than light, okay? Because, number one, you are an object with mass. Now, Einstein's theory of special relativity says that the object with mass approaches the speed of light. Its mass and energy, or the energy required to accelerate it further, increase exponentially. So the faster you go, the more energy you need to go faster. So as you approach, yes. So as you approach the speed of light, you need more and more and more and more energy in order to get closer and closer. We simply don't have the energy to do it. We would need an infinite power source. So that is problem one, even before the squashage in gravity.
But it's possible to travel at near the speed of light.
Maybe.
Without using an infinite amount of energy.
But you would still need a hell of a lot.
Yes.
So you have issues. Now, one of the things that I'm telling you now, I did not understand this at all. If you take a torch and you shine it at the ground, okay, the spot of light appears to move faster than light because the object is actually traveling faster than light because of the atomic structure. Now, here we're going into serious quantum physics. So what you're actually seeing is the reverse shadow of light on the objects you're shining the torch at. If we could understand that and harness that, we could travel faster than the speed of light, or at least near to it. Do I understand what I'm saying? Not even slightly.
I'm sorry, I'm going to have to definitely not going to apply.
Okay, this is quantum physics for people like Stephen Hawking, not for me. So, if you understood that, go and speak to the big universities. They want you. They don't want me. So, yeah. So what do you think, Mickey? Are you off to university, or are you going to just give up on that one?
Yeah, I give up.
Yeah.
Anyway, I'm sorry, my phone's battery is dying.
Oh, no. You see, if you had an endless power source, it would be different.
Well, I wouldn't have a
But alas. But thank you so much for being a part of it till now. It's been awesome to have you along. We love having you here, and you are welcome anytime. And I will see you in the next one.
See you tomorrow. What tomorrow Thursday? You have
Yes,
a live
tomorrow.
on Thursday.
Yes.
Oh, okay. Alright, I'll see you tomorrow then.
Cool stuff.
Good night. Bye bye.
Nighty night. Sleep well. Okay, so the next problem for you, Spooky. What are the problems with faster than light, what they call superluminal travel or supercausal travel? Okay, the special theory of relativity, not the ordinary theory, implies that only particles with zero rest mass can travel at the speed of light. So photons can, because they have no mass when at rest. You have mass, therefore you can't. Any particles that speed exceeds that of light, tachyons, have been hypothesized but never proved to exist. And if they did, their existence would violate causality and imply that time travel is real. Tachyons scientifically, at the moment, it's agreed, do not exist.
Can I pop in a word? Radiation.
But what is radiation?
It's energy. It's like light.
Okay, but what it isn't is a particle.
Well, is light a particle? Well, some
No.
people say light is a particle, but also a wave.
Well, you
Which,
see, it's what you would call a zero mass particle. So it functions in both ways. You are a positive mass particle. So that kind of stuff traveling really fast won't affect it because it has no mass. You have mass, so the moment I make you go faster, you will squidge.
radio waves.
Radio waves are not particles at all. They are part of an electromagnetic band, which is the other thing we're looking at.
There's information you can send
Yes,
at vast speeds.
information by variations in wave height. Now, if I could encode your DNA into a radio wave, then I could do a transporter.
It's still too slow.
Well, yes, but assumedly, radio waves are one level of a electromagnetic wave. What if I got a much, much higher one and used that instead? That would be faster, theoretically. But again,
Doesn't it
theoretically.
stop at the speed of light?
Well,
I mean, I think
that we're not,
according to
we don't know.
scientists, nothing can travel faster than the speed of light.
We, at
So
the
not even
moment, so we don't know, and that's the problem. If we figure that out, maybe but at the moment we can't do it. Now, we have reached our 2-hour limit, so tomorrow we are going to talk about traveling through black holes, wormholes. Does quantum physics have a say in any of this? What is quantum entanglement and quantum mechanics? And does it actually have any bearing on current science and real life? How would the transporter use quantum entanglement to work? What about phasers, lasers, and lightsabers? And a couple more interesting things, including invisibility. So if you're up for that, definitely come back tomorrow. There will be a whole ton more, and I can guarantee that I am confused about half of the science behind this. But nevertheless, it's
I also had a
interesting.
bunch of questions to ask, but okay.
Good. Well,
I'll
are they
ask
for
them
what we've
tomorrow.
said already, or is it for the stuff coming?
Well, we're going to continue with those conversations tomorrow, like the transporter.
Yes.
Um,
And quantum
like
entanglement.
if you're gonna use something like that, shouldn't you have like a machine or a device at the other side for it to work?
Thank you.
Because
There's the problem. Yes.
yeah,
That's where things fall apart. Because even if I can dematerialize you here, I need something to rematerialize you there. Not like in
yes.
Star Trek where they just appear because it works from the other side. Or maybe it could. We don't know. We shall see. But that is a challenge. Absolutely. And it goes back to how fast waves of whatever kind, electromagnetic, light, whatever, can be sent that side even through a wormhole.
Yeah, well, with quantum entanglement, it, it doesn't travel through. It doesn't
Correct.
travel.
It's
You
superposition.
manipulate a piece of matter here, and it manipulates it on that side.
Superposition.
Immediately.
Yes.
Yes.
Now, that is what we will get into because it does get a little heavy. Superposition of atomic structure, at least.
But is this also just theoretical, or
It's
can it be proven?
kind of still theoretical, but almost provable because of. So, I don't want to say it's
Doesn't
true.
that pop in with a spooky something at a distance?
Yes. The
Or
idea
Schrodinger's
of,
cat?
yes, definitely Schrodinger's cat. And the possibility of telekinesis. So, yeah, there are a lot of things, if it were possible, and maybe it might be, it depends. But it isn't now, at least. But that's where we will go. And yes, we will ask many, many questions, I hope, and come up with all kinds of things. So until then,
Cool.
work out your questions and we will do our best to answer them. Have an absolutely amazing evening further. Good night, sleep sweet,
Cool. See you
sleep
tomorrow.
deep. But maybe you don't need to sleep with one eye open, because with enough technology on our side, maybe we can overcome just about anything. Maybe.
Cool. Have a good night.
Ciao, ciao, man.